Hi everyone, my name is Jerry. Welcome to Learn Tech Studios. Today in the studio, I'm going to show you how to construct this handy circuit from just a few components. This circuit uses a 555 timer chip operating in DA stable mode. It puts out square wave pulses that will be used to flash two LEDs, and as a bonus, this same timer will operate an attention-getting buzzer located here. This circuit is useful for any alarm type application. First we will look over the circuit in a drawing that I made. Then I will point out what some of the basic components are. Then I will construct the circuit and bring you along so you can see how to make it for yourself. Let's get started. Hi, welcome back. Alright, this is a drawing I made for the dual alternating LED audible alert system package. I'm going to just show you some of the components that are in here that we're going to be constructing on the breadboard next. Right now, this is the 555 timer chip. It's an 8-pin dip chip made like this. It has 8 pins in it, and it's the kind that can be inserted into a breadboard because of the pins. They do have surface mounts of these type of chips, but this is a dip, and so it makes it easy for prototyping into breadboards. So the pins usually start from define pin 1, which is here. It uses a little indentation like I've shown you here. The same thing is on this chip. And if you start to the left of the chip, you'll count 1, 2, 3, 4, 5, 6, 7, 8 counterclockwise. And that's how the chip is usually laid out. As you can see, it's a very tiny chip compared to the drawing, but yeah. Next, this chip can be powered from anywhere from 5 to 12 volts, but we're not going to be going that high. I'm going to be using a 3.7 volt 18650 power cell. It's only 4200 milliamps, but I got a lot of current limiting resistors in this circuit I'm going to show you. I'm going to put this away for a moment. Okay, our next item would be some of the resistors that we're using. In this circuit, I'm using a 1000 ohm resistor like this, and this one has 3 color bands: brown, black, and red. It has a 4th band here for tolerance, which is in this case is gold, so it's only 5%. But this is a 1000 ohm resistor, and that's going to be resistor R1 indicated here, and that resistor would go across pins 8 and 7. Next, we have a resistor that's a 22,000 ohm resistor, and that resistor is going to go between pins 7 and 6. The bands on here are red, red, orange, so that's 22,000, and it also has a gold band making it 5% tolerance. I have another resistor coming off of pin 3, which is simply a 100 ohm resistor, and it's a current limiting resistor that I'm using in this circuit. And them color bands on here are brown, black, and brown, and this one also has a 5% tolerance property to it, and it's going to be used to help limit some of the current going into the diodes, because if you overpower the diodes with too much current, you can zap them. They'll just blow. They won't work no more. Next, I have a 100 microfarad capacitor I'm going to be using, and this one has polarities to it. It has a positive and a negative. This is the positive side of it, and usually on these packages you will see like a little negative sign, and that dictates that that pin should be on a negative rail of something, you know, in your circuit. So this is an electrolytic or electrolytic. I always say electrolytic, but it's electrolytic capacitor because it's polarized. And in that the negative pin of that capacitor will go to pin 1. The positive side of that capacitor will link up with pin 2 of the 555 timer. We have on the breadboard, I want to have a positive rail and I want to have a negative rail. When you see this symbol here on the line, that means that this rail is grounded or negative. And usually the other one is usually positive. That's your positive potential. In this circuit, I'm using a solid state buzzer module, and it can fire from 1.5 volts and up. It looks like this. It's a little solid state device. It gives off a buzzing sound. It's not a piezo element. It's a solid state buzzer, and we're going to use that in this circuit to work as an alarm device of some sort. So when the LEDs are flashing, the buzzer will also be giving off an audible alert, which some can find handy. And I will show you how to wire that in the circuit. But for now, essentially you can see here that I've drawn it here. One pin from the buzzer will go to negative ground, and the positive pin will run all the way to the pin 3, which is the same pin that's feeding the light emitting diodes. But one thing about that is that the voltage or current coming from pin 3 will go directly to the buzzer. It don't need a current limiting resistor in this case. As you can see, this circuit is quite simple. So I'm just going to show you. Okay, usually, I have as in this drawing here, pin 4 and 8 has to go to the positive potential. So I have it running, as you can see here, to positive, and I have pin 8 running to positive. Pins 1 needs to go to a negative potential, as you see here, is running straight to negative. Anytime you see these little loops over wires, that just means that those wires are not connected. You don't want those connected in any kind of way. They just on a drawing, it helps you to understand that the wires are not tagged together when they're looping over like that. This circuit will flash alternately due to the output from pin 3. When pin 3 is in the off mode, one LED will light up. When pin 3 is in the on mode, the opposite LED will light up because of the polarities of this LED that I have here. And I will demonstrate that when we put it together. We're going to have a blue LED. I chose blue and white. Well, this is blue actually. This is a blue one. And it has 2 leads on it as well. There is a cathode, which is the flat. If you find the flat space on the LED, the pin right next to it is a negative pin. And if you flip it around, this smooth rounded surface, the pin right there is going to be an anode or a positive pin. So that helps you to line it up. Like in this case here, this here would be the cathode. This would be the anode. As you know, anode going to the positive, cathode going to the negative direction. So that's what that is. And we have a blue one, and I have a white one. And, you know, that's how that one is. Okay, so I'm going to show you what the breadboard looks like. And here is a breadboard. And this is a prototyping board that helps you to assemble circuits and find out if they work or not before you make them permanent and put them onto a printed circuit board that you need soldering for. In this case, there's no soldering needed because as you plug things into the board, they connect to wires built into the board so they can be connected. And we're actually going to start now. I'm going to put our first component into the board, and that's going to be our 555 timer. I'm going to put that into the board. You just line it up with the holes and then just press it down. In this case, the holes are here for a particular reason. If you want to tie something to pin 1, you can either stick it in this hole, this hole, this hole, or this hole, and it'll all go to pin 1. If you move over, it won't hit. If you want something to go in pin 1 and you put it over in this line, you won't hit it because you got to think of this as a long wire. So whatever you want on this long wire, that's where you have to put it in this row. Same thing applies on all the pins that are here. So if you want something from pin 1 to pin 2, just put it right across from it. Like in this case, we are going to install this 100 microfarad capacitor. And remember I mentioned that it's polarized, so it has a negative and a positive. Well, in our particular circuit here, as you can see, the negative needs to go to pin 1 and the positive needs to go to pin 2. So we can just go ahead and do that. I'm going to plug that in right here. I want to try to plug it away from the chip as much as possible to make it easy to install other components. So I'm going to do it like that. Let me see what else I need to do. Actually, I'm going to move it over a little bit because I want to keep that, put it like right about there, I think. So right now we have the capacitor plugged into the circuit, and that's as you can see here, this is the same thing that's done here. We just plugged the capacitor to pins 1 and to pins 2. The positive potential of the capacitor is going to pin 2, and the negative is going to pin 1. Alright, now let's plug in some resistance. I'm going to use let me see if I can make this where we can see it all together. It'd be nice, right? Alright, here we go. Alright. I'm gonna put 1,000 ohm resistor between pins 7 and 8, and that's going to be this one, the brown, black, and red. I'm going to put that out here on it toward the edge of the board because I won't need to install anything past that point anyway. So right now we have the 1,000 ohm resistor in place. Now I'm going to install the 22,000 ohm resistor between. It's going to touch pin 7 just like this one did, and it's going to swing over to pin 6. And as we know, we go counterclockwise, so you go 1, 2, 3, 4, 5, 6, and I want that to be one of the leads that I touch. So I'm hooking this to pins 6 and 7 in this arrangement. So the 22,000 ohm resistor is on pins 7 and 6. The 1,000 ohm resistor is on pins 8 and 7. Right now, this circuit still has no voltage going to it or even linked up to it. We'll get to that in a moment. My next thing I want to do is I'm going to try to hook up a positive potential since I won't need nothing else for pin 8. I'm going to go ahead and hook up a positive voltage to that. I'm going to show you how we do that. On this rail, on this breadboard, I configured it where the outside rows on this side is positive. The inside rows on here are negative. And on this side, the inside rows is positive. On the outside, is negative. And, you know, by the color code, you can go by, you know, red is always positive, no matter where you go. I use blue here instead of black wires because I ain't have no black wire. But, yeah, you can use any color you like, but just remember which one is positive and which one is negative. Okay, I'm going to go ahead and try to bend the wire to get to pins 8 and to the positive rail. So we're going to just, well, no, not like that. I'm going to try to get this into the hole of the pin 8 and then into the positive rail. So we just did that just now. So this one, the positive is coming from here and it's going to pin 8, which is what we need. Let me fix that a little bit better though. Let me pull this out and put it just a little bit closer like that. So yeah, so like I say, any of these holes would be pin 8. It doesn't matter. I'm just doing it because I want it to be a little bit neat while I'm doing it so it don't get too junky on this board. Alright, next I want to hook up pins 4 and 8 together because we need that to be together. Okay, so we're going to put, this is pin 4, so I'm going to put one red lead on pin 4, and I'm going to put one red lead onto pin 8. well, let me move something around again. Let's see. Let's do it like this. Push this here and push this one here. I think that's a little bit neater. There we go. That looks a little bit better. What do you think? Alright, let me just straighten this up a little bit. Okay, now, there. That's good enough. Now I need a wire to go from pins 2 and 6. As you see here, there's a solid wire going from pins 2. It goes all the way, it jumps over these wires. It goes around the pin 6. There's nothing connected to it. It's just a straight wire. So that's what we're going to put together right now. So I'm going to put, let me see, I'm going to move this back just a little bit. I'm going to attach this to pins 2. If I can. Maybe I better use something else. So we're going to put this wire to pin 2. And then we're going to put it to pin 6. Like so. And we just push that all the way to it bottoms out right there. So now, if we double check ourselves, we can see that pins 2 and 6 are tied together. So as you see here, 2 going around to 6, 2 going around to 6. And then we have 4 going to pin 8, and so that completes that part of the circuit. Okay. Next, I want to try to configure the dual LED configuration. I got an LED here that has an anode and a cathode. We know the cathode needs to be going more toward the negative side. So we're gonna do that. We're gonna put the cathode in the board, kind of facing this way a little bit. So I'm just gonna put one here. I put one about here, I guess. Well, let me see. We can do it like that. Or let me see. I'll do it like this maybe. Okay, so now we have an anode and a cathode going on. Now, the blue LED, which is this one, its cathode needs to tag up with the anode of the other one. So all we have to do is find the cathode here, like we did. We know this is the anode side. Well, that pin needs to be, that cathode needs to be in that, need to be in the same hole that let me see, the cathode. Alright, sorry about that. My camera timed out, but I'm back. Okay, let's continue. Okay, the blue LED's cathode needs to be in the same pinhole with the anode of the white LED, and we have that here. I just put it in there. It's hard for you to see it, but that's what we did right there, if you can see. Okay, next we're going to put our current limiting resistor in place, because we need that to protect these guys. So in order to do that, I'm going to set that resistor here, and I'm going to try to run some jumper wires to help get between here, because it's going to be difficult. So let me see. I think the best thing to do first might be to run a power wire from the blue to the power rail. So we'll do that right now. I'm going to run some positive from here, and I'll show you where it's at on the diagram. I'm going to plug it into the positive rail here. And what that is that this blue LED has the anode supposed to be going to the positive rail, and that's what I just did just now. I made that happen right there. And then the let me see how I got this. Just a second, I'm trying to see. I'm going to run a wire from the negative side of this LED to the negative rail here. So we'll do that. And I hope it fits. We'll just see if it does. Okay, I'm going to try to get that in there. That's a negative rail here. And I'm putting the wire into that, and it's touching. So what's happening now is that I just attached the cathode to a negative rail. Even though it's not on this side of the board, it's over there, but it's the same thing. Now, I'm bumping the camera, sorry about that. Now I'm going to try to, I got to attach a wire to this midpoint, because remember, this middle point is heading for pin 3 via current limiting resistor. So we're going to use a wire for that. I'm going to use a jumper this time. And I'm going to pin it between the two. If I can get in there. Let me see if we can get in there. I hope so. Yep, we can do it. Okay, so I'm going to pin it between the two. And right now that is locked in to this point here. Now remember, we want a current limiting resistor to protect these. So, and this is it. This is our guy right here. There's a 100 ohm resistor. I want to take one side of that resistor and I'm going to attach the lead to the top part, and then the back end of that resistor is going to go straight to the straight to pin 3. So pin 3 is here, 1, 2, and 3. I'm going to put a jumper wire, small patch wire across. Let me see if I might have to move something around. I will. So I'm going to move this resistor over just a little space just to get it in the right spot. Now I'm going to show you what we got. Right now, the current coming out of pin 3 is going through a current limiting resistor of 100 ohms, and it's traveling over this wire and it's going to the midsection of the two LEDs and is attaching right here at this point, like we need to have it do. Next, the buzzer, the solid state buzzer that I wanted to include in this circuit is here. It has a positive potential and a negative lead, so it's positive and negative in this. And if you look real close, I think you can see that little plus sign on top. I don't know if it's going to show on this camera, but there it is anyway. So anyway, I'm going to place that into the circuit to make it all nice and easy. Okay, and I plugged in the same line that this negative wire is attached to the negative rail here, because I want one side of this buzzer is negative and the other side is positive. Now I'm going to place a lead to pins 2, no, actually pins 3 of the 555 10, but I'm going to remove this out the way just for a moment because I can't see what I'm doing under all of that stuff. Let me just move some stuff around. Okay, right now I got a positive lead running from pins 3 that's going to help feed this buzzer. So now I'm going to put my capacitor back in place where it was at. There we go. Now I'm going to move something over because I need this positive pin here to be in the same line as the as this red is going, and then I need to move the negative rail here over as well to about there. Now, and I believe everybody lines up and everybody's connected. There we go. So now this solid state buzzer has a positive power that it needs to drive. As the pin 3 pulses out, it's going to power this momentarily, and it's going to make it buzz, make a buzzing sound. Okay, so now that we have that, we have to complete the circuit. We're missing one thing. Remember, we need a negative straight wire to go from pins 1 to the ground. So I'm going to do that. I'm going to put some kind of way, fit this in there. I'm going to, let me see, first I'm going to find pins 1. I got it there. I'm going to push this wire into pins 1's terminal. And I hope you guys can see. I'm looking at something else right now while I'm doing this. Down, got it. Okay, now. Alright, that looks like pin 1 is tapped. Now I'm going to take another straight piece of wire and I'm going to run it to the ground of the power supply, and I'm going to run it to the other end of this wire like a little jumper, that's all. Now, even though there's no loopity-loop going on here, this blue wire and red are not connected, so don't get that confused. That's not connected. It's really still doing what I'm showing here as it's jumping over a wire or whatever. It's just jumping over. That's all it's doing. It's not connected. I'm going to look it over and see if we got everything complete. I think we almost have it here. Let's take a look. Let's see. Okay. In the circuit, we have to have a 1000 ohm resistor, 22,000 ohm resistor, and they're going from pins 8. Let me see, yeah, pins 8 to 7, and then from 7 to 6, as this configuration is showing. The capacitor is polarized, so negative pin 1 has to be negative. Make sure that's in there good. Yeah, pin 1 is negative, and the positive of the capacitor goes to pin 2, and that's true in this case. All right, then we have pins 4 and 8 gets a straight wire. Pins 2 and 6 get a straight wire. Okay, and then pins 3 needed to feed this these LEDs are going to be fed the LEDs by way of 100 ohm current limiting resistor, and that's what's shown here as this little squiggly line. That's what's shown. Okay, I'm gonna pull this down just a little bit so you can see. I know this kind of looks kind of messy up here at the top, but I'm trying to keep the mess to a minimum. All right. It looked like the circuit ought to work, and only one way to find out, I suppose, is to try it. But I like to double check everything. Okay, pin 5 is left free to hang open like it's doing. The buzzer has a negative pin going to the negative terminal, a positive pin going to pins 3 of the timer, and these two are turned opposite each other, so where the cathode of one is facing the anode of the other, and it's tapped in the middle. So as I from what I can tell, it looks like we may have put it together. Let's give it a whirl and see what happens. I mean, the worst thing you can do it and just blow up. No, it's a joke. It won't blow up, but it won't be pretty though either. Okay, first I'm going to hook up some power to the board itself. Just using some connecting boards. And remember I said I'm going to use this I like these 18650 power cells because they're rechargeable. Very, very handy. I'm going to hook up the positive piece here first, like that. That's the positive side. You know, as I made this adapter anyway and I put some bolts in it, and I did the same thing on the other side, but I put it one of the colors are red, so let it be find positive quicker. So that's why that's like that. Alright, so I'm going to connect a positive to it. Now, if everything works, what's supposed to happen is when I power this up, this timer is supposed to flash these two LEDs in an alternating manner, meaning on, off, on, you know, like alternating. At the same time, it should be putting an output tone that's audible where you can hear it. So let's just see what happens. Here goes nothing. Let's see. Oh wow, it works. Okay. So I guess our wiring worked out. As you can see, it is pulsing the LED back and forth, and it is giving off a sounding alert. So that's pretty much it. This circuit can be used easily for any type of alarming application that you might have, and I can actually make this much smaller if I want to put it on a circuit board and solder it together. But you can make this circuit and make it as small or big as you like. Put it in a project box and make it really nice. But that concludes this example of the 555 timer alternating LED audible alert. If you can, try to hit that subscribe button or try to like the video, and if you want, you can comment and let me know if you want to see more videos like this. But for now, I got to go.